In this video, I am going to solve the 16th problem from chapter 19. We give 90 joules as heat to a diatomic gas, which then expands at constant pressure. The gas molecules rotate but do not oscillate. By how much does the internal energy of the gas increase? So here they mention the gas is a diatomic, and the condition they mention as constant pressure. And by using the value of the heat as 90 joules, we are going to find the value of change in internal energy of the gas. So let's rewrite what is given in the question. In the question, they mention only the heat, which is 90 joules, right? Okay. And what is the gas? This is diatomic, right? And what is the condition? Constant pressure. Okay. For diatomic, as well as for the condition for constant pressure, molar specific heat at constant pressure, we studied the relation for the heat energy Q, which is equal to NCP delta T, right? Okay. And also we studied the rule for internal energy. What is the rule for internal energy? The internal energy is given by the rule NCV delta T, right? Now what I am going to do, I am going to divide these left hand sides. That means I'm going to, let's I just give the number for the equations. Let's we take this is equation 1, this is equation 2. And this is diatomic gas, so Cp takes the value at constant pressure. What's the value of Cp? Cp will take the value as 7/2 times of R. Likewise, this Cv for diatomic at constant pressure, Cv will take the value of 5/2 times of R. Now I'm going to divide the equation 2 by 1 because we are going to find what should be the change in internal energy. So divide equation 2 by 1. So I'm going to divide the left hand side. So change in internal energy over Q is equal to, right hand side I'm going to divide NCV delta T over NCP delta T, right? And I'm going to substitute the value of Cp and Cv here. By that, this equation will become change in internal energy over the amount of heat supplied, which is equal to N. Cv takes the value of 5/2 times of R multiplied by delta T over N 7/2 times of R delta T. I simply substitute the value of this Cp and Cv here. Now we can cancel the same term, so I can cancel this with this, right? And likewise I can cancel R delta T, and also we can cancel these two, right? So by that we will get the equation as change in internal energy over Q, which is equal to 5/7, right? And we are going to find the value of this internal energy. So I have to move this Q to the right hand side of the denominator. So by that, this equation will become change in internal energy, which is equal to Q multiply 5/7. And the Q is mentioned here as 90 joules, which is already given in the question. So 90 joules multiplied by 5/7. So now I'm going to calculate the value of the internal energy change, which is equal to 64.29 joules. Clear? That's it. This is the answer for this question. Thank you.